Welcome to another episode of Isabel Explains, and if you're watching this video, you probably just watched my previous video on structure of atoms explained in simple English. If you haven't and are a bit confused about what's the difference between atoms, elements, and isotopes, and how protons, neutrons, and electrons affect the behavior of each atom, go ahead and click on the link above and watch that one first so you don't get lost. You good? Alright then, in this video I am going to talk about that fancy word I mentioned in the previous video, ion, which simply means charged atom. I will explain why atoms have the capability of becoming positively or negatively charged, aka ions, and why hydrogen is the runt of the pack and can get away with having no electrons and no neutrons. So, now that we know where babies come from, atoms obviously, now we can talk about how those atoms interact with each other to form full structures like rocks, salt, organisms, wind, and everything else you see around you. There are three main types of interactions between atoms: ionic bonds, covalent bonds, and metallic bonds. Ionic bonds happen when atoms bond by donating electrons to each other. Covalent bonds happen when two or more atoms decide to share their electrons. And metallic bonds happen, well, when metals bond with each other. Today we will only be talking about ionic bonds, but for that, first we need to know how they even happen. We talked about how the nucleus has protons and neutrons, while electrons are pretty much orbiting, yes, new fancy chemistry word, around the nucleus. But what we didn't mention is that electrons don't just float around the nucleus aimlessly, bouncing against each other. That would be catastrophic. They're actually traveling through what we call, you guessed it, orbitals. Orbitals are pretty much like car lanes on a highway. You can only have a certain amount of cars next to each other at a time, right? Same thing goes for electron orbitals, except that these are two-lane highways that only allow a certain amount of cars at any given time. Very boring, but very safe. And that is because electrons travel in pairs, meaning that they don't just have a car by itself on the highway, they always have to have a car next to it. Otherwise, they just rather leave the highway altogether if they can't find another electron to pair with. Crazy, right? Also crazy, atoms want those orbitals to be filled at all times. Otherwise, there's no point in carrying these orbitals around if they're not going to be used. So how exactly does it work? Different elements have different amounts of orbitals, and that will depend on the amount of protons that they have. Remember we mentioned that in order for us to have neutrally charged carbon, it would need to have 6 electrons because it has 6 protons? Well, carbon would need to have enough orbitals to sustain those 6 electrons. Here's what's tricky. Orbitals are built in layers that we call shells. Atoms organize their electrons starting with the shell closest to their nucleus. That first shell can only hold up to 2 electrons. If the element has more than 2 electrons, it will need a second shell to put its electrons. The second layer can hold up to 8 more electrons, and if the atom has more than 10 electrons, it will need a third shell, and so on. The outermost layer of any atom is called, fancy chemistry word alert, the valence layer. Therefore, the electrons in it will be called the valence electrons. This layer is the only one that is allowed to interact with other atoms. What do I mean by that? This layer is the only one allowed to give away or receive electrons in order to satisfy the desire of the atom to have its last layer full. Now, here's a secret you should know about valence shells. They're lazy, and they will always do what's easiest for them. I think we're ready for an example.
Let's see what the valence shell of sodium would do when it interacts with another atom. Well, we find sodium on the periodic table and we see that its atomic number is 11, which means that it has 11 protons. Now, based on the mass of 23-ish, we know that it must have at least on average 12 neutrons. However, neutrons are not relevant when we're calculating the charge, so I'm not going to draw them. Since I have 11 protons, we know that I will need 11 electrons to have a neutrally charged atom. But we also know that the first shell only holds up to 2 electrons, so I don't need more than that. The second shell holds up to 8 more electrons, so that's better, but not enough. So sodium would need a third layer, which fits up to 18 electrons to fit all of its electrons. However, we mentioned that the ultimate goal, or the most comfortable state of any atom, is when they have their last shell completely full. That means that sodium has 2 choices. It can either try to recruit 17 electron donors that are willing to give up their electrons, or it can just get rid of that last electron by donating it to another atom and make the last shell disappear. Which one is easier? Find 17 people willing to give you money, or find one person willing to take your money? Finding someone to take your money, right? So that's exactly what sodium would do. Now, sodium would only have 10 electrons, but still 11 protons. Can it just give away a proton too? No, because then it would no longer be sodium, it would be neon. So what happens to sodium? Now it has converted into ionism. I'm kidding, I just made that part up. But it has now become an ion, a positive ion. More specifically, an ion with a positive 1 charge because -10, which is the amount of electrons, plus positive 11, which is the amount of protons, is equal to positive 1. How do we write it? Just like that.
Now, elements on the other side of the periodic table, except for noble gases, they don't like to interact with anyone, will have the opposite behavior. Those are the salesmen of the world. They find other atoms to donate electrons to them because their shell is almost full, and they rather take electrons from other atoms than to give away a ton of their own. That's why they tend to become negatively charged. Just agree. When these donating/receiving interactions happen, we call them ionic interactions. Now, because one of the atoms is going to become positive and one will become negative, they will not just donate electrons and leave. They will actually stay together and form an ionic bond because their charges attract to each other. Ever heard of opposites attract? Hate to break it to you, but that's where it came from. Not so romantic now, huh? When they unite, the structure that will form is called an ionic compound, and then they'll live happily ever after. Or until a reaction happens or they're put in water. But that's a topic for another day. Thank you so much for watching. If you found this video helpful, don't forget to hit like so you can help other students find it easier. If you haven't done so, make sure you subscribe to my channel below to help support my cause of free tutoring, and I will see you next time. Wait, I didn't explain why hydrogen is the runt at the back. Well, simple. Hydrogen has 1 proton and its mass is 1, which means it has no neutrons. It only needs 1 electron to become neutral, but its layer can hold up to 2 electrons, so it can either receive 1 electron to fill up its tiny layer, or it can just give away its electron and carry no layers. Which one do you think it chooses more often than not? Giving away its electron. Told you, lazy. Fine, I'm done now. Bye!